Stability and determinacy of trusses. The geometric instability having a square vent. For this truss, we have our reactions. Those are members 1 and 2, and having a cut in those two members, which separates the truss into two separate parts. We consider, for example, the right part here. F1 is the force in member 1. The red F2 here is the force in member 2. And we can observe that sigma forces in the y direction equals 0. This equilibrium equation is unfulfilled because there are no vertical forces that maintain equilibrium with the vertical YB. This is the geometric instability. Another example is this truss having a cut here, and considering any part of the two cut parts, we can conclude similarly that YB has no other vertical forces to maintain equilibrium with it. We say that the equilibrium equation in the y direction is not fulfilled. To stabilize the first truss here, we just add a diagonal member to have triangular vents instead of square vents. Those are our reactions and our members, having a vertical cut in the truss and extracting one part of it. We analyze the inclined force, the force in member 3, to a horizontal and a vertical component. And fulfilling sigma forces in the y direction equals 0, we can write that YB minus F3 sine theta, all forces in the y direction, equals 0. This means that the equilibrium equation in the y direction is now fulfilled and F3 sine theta maintains equilibrium with YB. Another example for the geometrically stable truss is this truss. Either we add a diagonal member here, or we can add a diagonal member in the upper square vent here. So having three-chorded truss, we can have this three-chorded truss. Those are our members, and having a vertical cut in those members, we can observe that YB is stabilized with the vertical component of the force in member 3. So we say that the equilibrium equation in the y direction is fulfilled. To sum it up, the upper two trusses are geometrically unstable trusses. The lower two trusses are stable trusses. Statical instability. Statical instability is encountered when equations are greater than unknowns. The number of equations are greater than the number of unknowns. J equals the number of joints, M number of members, R number of reactions. E is the number of equations of equilibrium and is equal to 2 multiplied by the number of joints. This is because, as we mentioned before, at each joint we have two equations which can be fulfilled. Sigma forces in the x direction equals 0, and the other equation is sigma forces in the y direction equals 0. The unknowns are m plus r, which means that the unknowns are the internal forces in the members and the external reactions of the truss. Now considering this truss and those reactions, we can count the members 1, 2, 3, 4, 5, 6, 7 multiplied by 2 because they are the same on the other side equals 14. So we have 14 members. Counting the joints, we have 1, 2, 3, 4 multiplied by 2 because they are the same on the other side equals 8 plus 1 common joint here gives J equals 9. And we have 3 green reactions here. So the unknowns are 14 plus 3 equals 17. The equations are 2 multiplied by J, 2 multiplied by 9 equals 18. And the equations are greater than the unknowns. Therefore, this structure is unstable, statically unstable. We have our example here, another example with our reactions, and we start counting our members. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 multiplied by 2 for the other side, which makes members equal 24 members. Start counting our joints. We have 1, 2, 3, 4, 5, 6 multiplied by 2 equals 12 plus 2 common joints between the left and the right part. So 12 plus 2 equals 14. This is the number of the joints. We have 3 reactions and the unknowns are 24 plus 3, M plus R equals 27. The unknowns again are the internal forces plus the external reactions. The number of equations are 2 multiplied by the number of joints equals 28. The equations are greater than the unknowns, therefore this structure is statically unstable. To proceed with statically indeterminate trusses, those are trusses having the number of unknowns greater than the number of equations. So we have here 8 members, 4 external members and 4 internal members. The number of joints are 5. They can easily be counted. And the reactions are 3, so the unknowns are 11 and the equations are 10. The unknowns are greater than the equation by 1, therefore this structure or this truss is stable and once statically indeterminate. Truss here, members are 16, joints are 9, reactions are 4. The unknowns are 20 and the equations are 18. The unknowns are greater than the equations by 2, therefore the structure is stable and twice statically indeterminate. We can note that these two redundants are one internal force and one external reaction. So we can really distinguish the redundants or the extra unknowns are internal forces or external forces. For our last truss, we have 21 members, 11 joints, 3 reactions. The unknowns are 24, equations are 22. So our truss here is stable and twice statically indeterminate.